Okay, so we've got the test coming up, and on the test there is a formula page in the back of the book, and you'll be told again and again that you can refer to it throughout the test to help you. But it's really important that you understand what these formulas actually mean. So let's look at this one formula at a time very quickly, and I can just explain things, make sure you understand. So first we have the exponent properties, which we studied very early in the year. It's been a while. So let's talk about the first one right here. Let me switch the color here. A to the m power, which a is just some number, and then the same number raised to a different power. What we learned this year was that when we multiply those two things, that it's the same as adding the exponent. So for example, if I said 3 to the second plus 3 to the third, that really means 3 times 3, which is this part, times 3 times 3 times 3, which is this part. And altogether, that means I've got 5 3's being multiplied. So that's the same thing as 3 to the 5th power. That's the first one. This next one is when I have a power that's raised to another power. So for example, 2 to the second, and then if I were to raise that to the third, that means 2 squared times 2 squared times 2 squared. That means basically I'm taking this thing right here and multiplying it by itself 3 times. So if I break it down even further, that just means that we've got 2 times 2, which is this one, times another 2 times 2, which is basically this, times 2 times 2, which is this. So altogether, that's 1, 2, 3, 4, 5, 6, which is 2 to the 6th. And the shortcut there is that 3 times 2 is 6. So that just kind of saves us time if we want to do it that way. This is the one that we spent a lot of time with, where we had numbers on the top of a fraction and the bottom. And so let's say we had 4 to the 4th over 4 to the 2nd. Well, what we know is that that's 4 times 4 times 4 times 4, right? That's what exponents tell us, right? It's this number that many times, and that's why it's 4 to the 4th. Now in the bottom we'd have 4 times 4. And as we learned, 4 divided by 4 is just really just 1, right? So we've got that going on, 1 and 1. And so really it's not z, it's equals 4 times 1 times 1 times 4, which equals 16. But what's also true is that 4 times 2, or sorry, 4 minus 2 is 2, and 4 to the second is 4 times 4, which is 16. Now, when we learned this year, we didn't really look at these shortcuts. We did it the old-fashioned way, but now the shortcuts are here for you. The last one is this right here, which I hope you remember is when we had negative exponents, we wound up basically moving them from the top to the bottom or from the bottom to the top, depending on the situation. So what we know is that 3 to the negative second power is the same thing as 1 over 3 to the positive second power. So remember we said stay or go, and we moved negative exponents back and forth, and that's what that's all about. We spent a lot of time recently on this, the slope, and we talked about it as the change in y over the change in x. Now the formula tells you that you subtract the two y coordinates and the two x coordinates to find that information. And that's technically true. I chose to present it to you all in a way that I thought was easier to understand, which is just finding the change. But the way we find the change is the subtraction process. And then we also learned that in a linear equation of this type right here, that this number, whatever it is the slope, and this is the y-intercept. So if I had an equation like y equals negative 3x plus 4, what we know is that the slope, which is this number, would be negative 3. Oh man, that's really an ugly 3. Wow, sorry about that. And then that the y-intercept, which is this number, would be 4. And then what that means is that if I graph this function, it crosses the line, or the y-axis, I should say, more specifically, at 4. We didn't get a chance to get to triangles this year, but if you look at a situation like this, and you'll see some, if you have a right triangle that has these two sides that are called legs labeled, and then this side's called the hypotenuse. It turns out that in every right triangle, and you may have seen this before, this side length right here squared plus this side length right here is the same as this one. So just generally speaking, what that means is that if I took and made a square out of this, and I also made a square out of this by using, squaring them and using a perfect square, that would be the same thing. These two amounts of area would add up to the same as that. Now, mathematically, what it means is that if I had, let's say, 3 and 4, that 3 squared, which means 3 times 3, so let's call that one 3 on a side, which means 9. 3 by 3, the area would be 9. And if this one was 4 by 4, that would be 4 squared, which means the inside, the amount of space that takes up would be 16. So 3 squared plus 4 squared. So backing up, we have this. 3 times 3 is 9. That's a square. Four times 4 is 16. That's also a square. Those two things together equal 25. And that means that this third square, I'm going to use a different color here, this third square has a total area of 25, and that's whatever c squared is. This squared plus this squared equals this square. Well, we know that if c squared equals 25, what number do I multiply by itself to get 25? We studied this way back in the beginning. That number is 5. All right, now we get to volume. Volume is how much stuff. How much stuff could I fit inside this if I filled this thing with Mountain Dew or, popcorn or ground up Pringles or whatever? How much stuff could I put in there? That's what volume is. Volume is a measure of how much stuff you can put in 3 dimensions. And so when we do volume, let me just erase all that junk by making this bigger. The way to calculate volume is to take the area of the bottom part, which is how much if this was like a floor, for example, how big is that circular rug, and then go up and say how many, if I thought about like Pringles, for example, like if I thought I could put a perfect little circular potato disc here and then I just keep stacking them up, how many could I fit this way? So how big is the Pringle, let's say, and then how many would I fit in there? That's basically what volume is telling us. So the way to do that in the terms of a cone, just erase all this junk so you don't get confused. The way to do that in terms of a cone is to say, well, how big is this area, which is pi r squared, the area of a circle is pi. Remember Pi Day when I bought all the pies and we ate them? That was fun. R squared, radius is r squared. And then we multiply by the height, which is this right here. But then it's not the whole thing, it's only a third of it. So that's what we do. We take, if it were a can, like a cylinder, it would just be this by how many tall it was. But it's a cone, so we're only taking a third. Now imagine this is like the cone again, but now it's the whole thing. It's not just the cone, it's the actual Pringles can, if you will. So we think about it a little bit. This one's a little bit easier. This one's basically just how much space area-wise does this take up, which is again calculated by pi r squared. And then how high is it? That's the height. So that just tells me how many layers I have, and that's what the volume is. All right, last, which is like a basketball. How much stuff could you stuff into a basketball, for example? And so this one is, again, based on how big this circle is, which is pi r, but now it's cubed, and the reason it's cubed is because now we're moving in three directions: length, width, and also, I guess you'd call it height or depth. So we've got, we're going this way, and we're also going this way. So it's cubic because we're basically taking the amount of stuff we could fit into a three-dimensional figure. So you take the pi, you take the radius, multiply it by itself 3 times, and then multiply that by 4, and then finally divide by 3. I know I've thrown a lot at you very quickly. I hope this gives you at least a little bit of a chance to understand what these formulas mean on the page, and I'm sure you guys will do an awesome job.